I was always a guy who really liked to show instead of telling, so I created this presentation directly in Unreal Engine, so you can enjoy it with me together. So I constructed this 3D gallery to show my presentation. I'm going to talk a little bit about myself and the studio that we are running, about how we introduce web3 game development solutions to Unreal Engine 4 and 5, all the advantages and trades-off of using web3 elements in the game, and what, in my opinion and in my professional opinion, knowing everything that's happening in this space, is going to happen in the future. So, we are 3S Game Studio. We are a small indie game development company established in Estonia this year, so we're not even 1 year old. Everyone on the company is senior staff, book writers, PhDs, evangelists, and people who has usually over a decade of experience in game development, and usually similar experience in Web3 development. We solve every problem that we have with code. We are lacking, for example, any stuff regarding graphic design. So we just learned how to do AI, and now we have an amazing concept artist that is also providing all the backgrounds for some of the slides. We are self-funded, so we have no external investors. Yeah, we have already delivered 2 products onto Unreal Engine Marketplace, so they are available throughout the public. We are not developing tools that we are only using internally. We want to share those tools with everyone who wants to use them. So where we are right now. Like I said, we started a year ago, and we established a really nice cooperation with companies like Polygon, IPFS through Firecon Foundation. We are also receivers of a grant that helped us build the IPFS installment that I am using right here in this presentation. We're also in very good relations with Epic Games, and all our products are accessible on the marketplace. So from the 2 products that I mentioned, one of which I'm going to talk really briefly is the blockchain plugin. So the blockchain plugin is a full implementation in C++ of the entire EVM. So there are multiple solutions on the market when it comes down to Ethereum or any other EVM blockchain implementation into Unreal Engine. But this is the only implementation that has full cryptography, key generation, transaction signing, and communication with the nodes directly from the engine. So there is no third party involved in this communication. There is no relay server that someone is pushing on you as a service. It is platform agnostic. It works on consoles. It works on mobile. It implements full math, 256-bit math and cryptography, and all the hash functions that you need to run basically any blockchain. The basic implementation uses EVM, but it is very simple to implement by yourself, for example, Bitcoin or any other blockchain using those tools. We also ship with full source, which means that you can do a security audit, you can modify the source, you can extend it however you want. And we are Unreal Engine 4 backward compatible, because we know that there is a lot of products already in development that are still stuck with Unreal Engine 4. I got next slides on this wall. So the second product for Web3 stack that we have developed is IPFS. And in my personal opinion, that is a more relevant and important product to game development overall, and I'm going to tell you exactly why. So, IPFS, what it does and how it works, you already know. But when it comes down to gaming, it allows to do some things that requires a lot, and I mean a lot of extra work when it comes down to building backend for a game in order to solve issues that IPFS solves immediately by just the nature of it. So for example, you are allowed to very easily share content in between players by just sharing CIDs of the content created and uploaded. You can create in-game really complex assets like entire buildings, character design with multiple morphs and visual elements selected, store them as just JSON data and distribute it through IPFS. You can also distribute images, and you can stream them and parse them into 2D texture directly through IPFS, which means that you can use render targets to literally draw anything inside the game, then store it as a texture and share it with other users. You can, of course, download, upload, and stream content. How you are using IPFS in gaming depends on how the developer wants to use it. It allows for very easy NFT support inside gaming. And this product works without blockchain, actually, because if you are supporting just a single NFT contract, all you need to do is just query the wallet itself with any service and just get the CID of the metadata. It also allows to store and share binary assets, which is very important. So for example, you can store any custom structures inside the game, references to objects or references to classes inside a save game file. And those files already have implementation of saving to disk and the loading from it. And they are highly compatible with even sharing content in between games. And most important, you are in control. You decide what you want to preload, what you want to unload, what you want to delete or store. So for advantages, like I said, you can share user-generated content of any complexity and size. You can share content for DLCs and patch for games that are data-driven without the need of restarting the client. So you can patch a game literally in middle of a session and even change the balance of weapons without users knowing about it and without the need of restarting the client and doing the entire patching process. I don't know how many of you ever launched a game on Steam, but making a build that is an incremental build and patching it on Steam so every users are on the newest version and they are in sync with the dedicated server is a process that takes multiple hours. While with IPFS, you can enroll a hotfix patch within minutes. You can do cloud saving of any type of data immediately without the need of using any third-party services. It is asynchronous in its nature, so it's not really an impact on performance. And assets are being loaded on client, which is very important for multiplayer games, where number of data, how much data you are syncing in between clients and server and then multicasting to all clients is very important. So if instead of sharing very large amount of data, you can just share a CID that is pointing to a data that can be recreated on each client locally, then you are saving a lot of bandwidth, which is especially important for large-scale multiplayer games. There are some trade-offs, of course. So assets are, of course, not instantly loaded. So you have to keep in mind when do you want to start loading the assets, how long it could take. In most cases, you can preload all the assets while all the players are still in the lobby waiting for the match to enter, to start. And this is a fast process, but you just have to keep it in mind when designing the game. Upload usually is a lot slower than downloads of those assets, and this is not only the fault of IPFS, it's mostly on the internet service providers. But most of the assets that you do download are pre-generated by the game developers, so this is not really that much of an issue. Multiple unique artist assets increase draw costs. So what it means that The more assets that are unique and created by users you call into the game, the bigger the performance hit will be because you can't instance all of this at the same time. And you just have to keep in mind the size of the texture streaming and what is the memory impact of the entire game. However, once again, if you are loading assets generated by the developer, it's usually not an issue. You can curate content, which means that if you allow, drawing literally anything on a banner that you can put in a game, you can be sure that someone will draw something very not okay. So you will have an issue with inappropriate images and copyright infringement. But I know that there are multiple teams working in IPFS that are focusing on curating inappropriate content for the network itself. And currently, the limit of uploaded content from the client size in our implementations is 100 megabytes, but download size is of any size. So you can generate a very minimalistic installation file for the game that you are developing, and then the rest of the game can download as it goes. So, for who is this product really? First of all, of course, for Metaverse and Web3 multiplayer games. This is obvious. We started developing the two tools that we have delivered on the market because we needed them ourselves. And there was nothing that was even close to it currently on the web. I know that there is a lot of really great tools that are being developed right now for different engines and different use cases. But yeah, this greatly improves the speed that you can develop Web3 games. It also helps you to port Web2 classic multiplayer games into Web3 space. Implementations of those assets is really easy. It is also helping single-player, user-driven games. For example, if you have a game that is similar to Sims, and you have some way of building houses or decorating interiors or creating really complex game assets, and you want to share them in between players, IPFS is a very easy way to do that. And actually, it helps any game because it helps distribution of patches, DLCs, and any downloadable content that a game can benefit from. So the goals for the next year for our company is to, first of all, of course, improve on the assets we already delivered. We also want to make a Unity support and implementation for both blockchain and IPFS. We want to have it on the same level of support and the same functionality as the tools already in place. We also need to introduce IPNS and some other cool feature of IPFS technological stack that will allow to deep version and really allow easier distribution of incremental content. And the last part that we are working on right now, and we already have a working version, but we'll still, fine-tuning the details, is a pack loader automation. So basically, in Unreal Engine 5, you can generate pack files when building a game, and you can load them and mount them into the game dynamically on runtime, which means that you can fragment a game by content, by folder, by asset types, and you can make a distributed build. So this is great for modding support because that means you can just make a guideline of how to mod your game and create a trimmed down version of the entire project to ship just for testing for people, and then can generate pack files for your game specific as a mod without you having the need of shipping the entire game for the modding tool. So one of the issues of games, like for example, Conan Exiles, is that when you are downloading the modding tool for Conan on Unreal Engine launcher, you are actually downloading the entire source of the entire game that contains all the assets and all the data tables. And using this tool, you can reduce the package size even up to 98%, which sounds insane, but this is exactly what we did in a demo where we had over 2 gigabytes of content that we were able to trim down to 39 megabytes. And the rest of the content was downloaded or streamed on demand only when certain map or certain assets were required. So the installation imprint of the entire game was greatly reduced. So about the pack loader. Okay. So Unreal Engine 5 also introduced something really cool, which is called the modular gameplay features. Modular gameplay features is the new way of making games when all the content packs are encapsulated in itself and they don't really refer to other content packs. When you are building a game this way, all of the packs can be loaded and unloaded independently of each other. Which means that you as a developer can fully control what assets you need to have on the drive or have in the memory while loading certain maps or certain game features. Which means that you might have a game that contains, for example, single player and multiplayer content, and you are only interested in the single player campaign, which means that you can save even tens of gigabytes of content by just excluding everything that is multiplayer that is not relevant to the gameplay experience that you as a player are looking for. It is a very big issue right now, especially for consoles, where installations of games are taking just amazing amount of space. For example, the new Call of Duty is 150 gigabytes of installation just on the version 1.0, the one that is here on the release. Which means that as the game grows and as the new content is being developed, this installation will only increase. And the smallest disks for consoles currently is 320 gigabytes, which means that if you install Call of Duty, you barely have place for just one more game. Another cool feature, what I also mentioned, is that you can load the content without the need of resetting the game. So you can introduce balances or load any visual features without the need of restarting. You can also use data layers, data registries, and soft references to utilize the full power of this, but I'm not going to go into details. And this is extremely useful for mobile and console games, like I mentioned. So this is basically modding of games, easy mode. You don't need to distribute full source of your game to deliver a trimmed down version for modders to create content for your game. So let's talk about future of Web3 gaming in general. Oh, wait. So I think the biggest myth of Web3 that all the skeptics are always saying that, oh, you cannot share assets in between games. What everyone is promising with Web3 and Metaverse cannot be done. Well, it can. It actually can, and I can prove it. So asset sharing. You, of course, need to always keep in mind how the assets are being prepared and how they are being shared in between projects. But this is definitely can be done, and it can be even done in between engines. So using the gameplay features and encapsulated references, you can generate a package that can be loaded basically into multiple games if it is being properly built. Skeletal meshes are the most complicated assets to be shared in between games, which means there's skin meshes, so characters, weapons, stuff like that, mostly characters. So all the characters being used in game development in general are actually following only 38 skeleton archetypes that are being commonly used. It can be, from Blender, it can be Maya Advanced Humanoid Rig, it can be DAZ Studio 3D Character Creator Pipeline. Whatever it is, you have certain archetypes of how humanoid characters are being portraited, and you can pre-prepare all of those skeletons inside your game. And when you are importing an asset from outside of your game, you just have to be able to identify what kind of skeleton it is using. And when you just pinpoint and point the skeleton to the asset that you are loading, you can use the animations that you have prepared for that skeleton already. You have now amazing tools inside Unreal Engine, just like IK Rig Retargeter, Pose Driver, and Full Body IK Solver, which means that you can even load assets that you do not know the archetype of the skeleton for. And you can still retarget full body animations onto the skeleton and animate it with animations that you have prepared for a completely different skeleton. If you know the schema of metadata of any metaverse asset that has JSON data, it's just the way that you interpret it inside your game. That can be different from interpretation inside another game, but it's still very much doable. And loading external assets is like loading mods. Modding game is not a new concept. It exists for a very long time, and we are already doing it. So saying that it's impossible to maintain is simply not true. And yeah, you can either prepare assets separately for Unreal and Unity, or you can load basically anything with certain file standards, like the GLTF runtime. So you have the GLTF or GLB files, which are binary files that can hold basically the entire character, textures, and PBR materials in a single file, and they can be hot-loaded into the game directly. And a good example of who is doing that is Ready Player Me. And those characters can be used in any engine. So it is very much doable. So my predictions for 2023, what's going to happen to the metaverse and Web3 space in general, is that we are going to develop a lot of games that are being streamed or in this rental service like we have Game Pass, when you have not directly streaming of a game which is being run like remotely and just streaming the pixels into your monitor, but you just have a monthly payment that allows you to download and play games that are in the service. And we're going to see more and more of that, definitely. When it comes out to the metaverse race, there is actually already the metaverse that is like the metaverse of all metaverses, which is called the Omniverse. It's created by NVIDIA. And it's an amazing tool that allows multiple people collaborate on a project that can develop and ship elements that are being built in completely separate pipelines. So one person can work on characters in, let's say, Reallusion pipeline, and another person can make other elements, visual, like the scenes and lighting, inside Unreal Engine or maybe inside Blender. And they all can come together in Omniverse. So it's a very omnipotent tool, and it sees more and more implementations into different external applications, as we see. And yeah, I think that we will see a lot more AR features, because everyone has a phone in their pocket, and VR might share the fate of 3D television. I don't know if many of you remember the craze of the 3D TV that was driven by Sony. And everyone wanted to have one, but currently no one even produces 3D television. So, yep, sorry, Mark. I don't think that your metaverse is going to catch up. And we're going to see a lot of crossing of brands, which we already see. So basically, if something exists, it probably has some features in Fortnite, right? Like, I'm not up to date exactly with Fortnite, but any celebrity, any pop culture reference, and any TV series or a movie basically has its second life in Fortnite. We currently also see crossing of products that we never seen before, like, for example, Magic the Gathering crossing with Warhammer, which are being driven by two competing companies who are in fantasy tabletop gaming for a few decades. They never crossed their products. They were very careful about how they are using their brands, and now they are crossing in between each others. And we see a lot of physical brands that are being introduced into metaverse space. And with the content sharing in between games, we're going to see a lot of reusability of those metaverse content as it goes. So for everyone who is developing a game in Web3, please remember, you are making something that is part of entertainment. You're not creating a virtual job, and play-to-earn model as a whole is not the best model, because if you spend 8 hours in your job, the last thing you want to do when you come back home is to spend another 8 hours in a virtual job. You want to just relax. You want to have fun. You want to escape from this world that is being harder and harder to live on, and you want to escape into something that is just cool and amazing, and you want to spend time mostly with your friends that you meet online. And we have lost a lot of that when the first Web3 games were developed. But I know about many products that are being in development right now that are emphasizing on game first and monetization and everything else just second. Like, Web3 is a great stack for developing games. It really increases the speed of introducing some of the multiplayer features, but it is also so easy to get lost into just all the cryptocurrency stuff. So please put the game first and investment second. And thank you.